Alright, so I'm going to do a video on rational numbers. And rational numbers are just part of the real numbers. And I'm going to explain all this in 1 second, hopefully. And I'm going to also try to write so you can read numbers. Alright, so this is going to be video number 1. If I asked you to record some numbers, you might record, just pick random numbers. You'd probably pick numbers like 3 or 8, 12, and these are all fine. These are all perfectly good real numbers, and I'm sure you'd agree that they are real numbers. And there's no argument about that. If I asked you if you could rewrite 3 somehow differently, you might say, well, I know that 3 is the same as 6 divided by 2. Or 3 is really the same as 3 over 1. And that's fine. It just shows that a whole number, like 3, can be written as a fraction. Or, as I like to say, a ratio of 2 numbers. And if you take a look, the word ratio is in the word rational. So my point is this. If you can write a number as a ratio of 2 numbers, or a fraction, it is a rational number. So whole numbers, such as 3, are rational. Numbers like 6 over 2 are rational. So you might say, well, what if I had something like this, 6 and 2/3? What kind of number is that? Is that still a rational number? Because 6 is kind of a, it's a little bit strange because it's with a 2/3. It's called a mixed number. Now, if you remember, this 6 here is a whole number, and this is a fractional part. So what we're actually looking at is how many thirds do we have? Well, how many thirds would 6 be? If I had 6, 1, 2, 3, 4, 5, 6, and I broke these all into thirds, I would say that I have, and these are supposed to be equal thirds. I know they're not. But I would say that I have 3, 6, 9, 12, 15, 18. I have 18 thirds, which is the same as 6. And 2 more thirds, which is 20 thirds. Well, I just said that if you can make it into a fraction, or a ratio of 2 numbers, it's a rational number. So, mixed numbers are rational. And this is now an improper fraction because the numerator is greater than the denominator. And once again, you can see that's still a rational number because it's ran as a ratio of 2 numbers. There's one other type of number, that we are going to investigate, and that's a decimal. Let's say I've had a 3.2. Well, the 2 is in the tenths place. And so if I really want to rewrite this as a ratio of 2 numbers, I just write down 32 tenths. And you can see it's an improper fraction, but we just said that improper fractions were in fact rational numbers. This can actually be reduced down as well into, I could divide this by 2. Well, 32 is really the same as 2 times 16, and 10 is really the same as 2 times 5. And since they have a common factor of 2, I get 16 over 5. And that's it. All right, so rational numbers. Whole numbers, like 3. Fractions, like 6 over 2. Mixed numbers, like 6 and 2/3. And improper fractions, like 16/5. These are all rational numbers, and rational numbers are all part of something called the real numbers. Coincidentally enough, I just want to throw in one last tidbit. If I negated all of these and made it all negative, these would still be rational numbers. There is one little part left, and that is, what about a number like 0.3 repeating? And I'm going to use these squiggly equal signs to show that it's 0.33333, and it goes on forever. What about a number that repeats forever? Well, luckily we know that 1/3 is the same as 0.3 repeating. And I'm not going to explain why that works right now, but you can see that repeating decimals are also rational numbers. And that's it. I hope you found this video useful, and I'll see you soon.